Metal fabrication is the building of metal structures by cutting, bending, and assembling processes. It is a value-added process that involves the construction of machines and structures from various raw materials. A fab shop will bid on a job, usually based on the engineering drawings, and if awarded the contract will build the product. Large fab shops will employ a multitude of value-added processes in one plant or facility, including welding, cutting, forming and machining. These large fab shops offer additional value to the customers by limiting the need for purchasing personnel to locate multiple vendors for different services. Metal fabrication jobs usually start with shop drawings including precise measurements, then move to the fabrication stage and finally to the installation of the final project. Fabrication shops are employed by contractors, OEMs and VARs. Typical projects include loose parts, structural frames for buildings and heavy equipment, and stairs and hand railings for buildings. Processes. Cutting is done by sawing, shearing, or chiseling, torching with handheld torches, and via numerical control cutters. Burning is done by hammering via press brakes and similar tools. Modern metal fabricators use press brakes to either coin or air bend metal sheet into form. CNC-controlled back gauges use hard stops to position cut parts in order to place bend lines in the correct position. Offline programming software now makes programming the CNC-controlled press brakes seamless and very efficient. Assembling is done by welding, binding with adhesives, riveting, threaded fasteners, or even yet more bending in the form of a crimped seam. Structural steel and sheet metal are the usual starting materials for fabrication, along with the welding wire, flux, and fasteners that will join the cut pieces. As with other manufacturing processes, both human labor and automation are commonly used. The product resulting from fabrication may be called a fabrication. Shops that specialize in this type of metalwork are called fab shops. The end products of other common types of metalworking, such as machining, metal stamping, forging, and casting, may be similar in shape and function, but those processes are not classified as fabrication. Overlap. Fabrication comprises or overlaps with various metalworking specialties. Fabrication shops and machine shops have overlapping capabilities, but fabrication shops generally concentrate on metal preparation and assembly as described above. By comparison, machine shops also cut metal, but they are more concerned with the machining of parts on machine tools. Firms that encompass both fab work and machining are also common. Blacksmithing has always involved fabrication, although it was not always called by that name. The products produced by welders, which are often referred to as weldments, are an example of fabrication. Boilermakers originally specialized in boilers, leading to the trade's name, but the term as used today has a broader meaning. Similarly, millwrights originally specialized in setting up grain mills and sawmills, but today they may be called upon for a broad range of fabrication work. Ironworkers, also known as steel erectors, also engage in fabrication. Often the fabrications for structural work begin as prefabricated segments in a fab shop, then are moved to the site by truck, rail, or barge, and finally are installed by erectors. Raw materials. Standard raw materials used by metal fabricators are plate metal, formed and expanded metal tube stock, welding wire, welding rod, casting, cutting and burning. The raw material has to be cut to size. This is done with a variety of tools. The most common way to cut material is by shearing. Special band saws designed for cutting metal have hardened blades and a feed mechanism for even cutting. Abrasive cut-off saws, also known as chop saws, are similar to miter saws but with a steel cutting abrasive disc. Cutting torches can cut very large sections of steel with little effort. Burn tables are CNC cutting torches, usually natural gas-powered. Plasma and laser cutting tables and water jet cutters are also common. Plate steel is loaded on a table and the parts are cut out as programmed. The support table is made of a grid of bars that can be replaced. Some very expensive burn tables also include CNC punch capability, with a carousel of different punches and taps. Fabrication of structural steel by plasma and laser cutting introduces robots to move the cutting head in 3 dimensions around the material to be cut. Forming. Forming is a process of material deformation. Forming is typically applied to metals. To define the process, a raw material piece is formed by applying force to an object. The force must be great enough to change the shape of the object from its initial shape. The process of forming can be controlled with the use of tools such as punches or dies. Machinery can also be used to regulate force magnitude and direction. An example of machine-based forming can also combine forming and welding to produce lengths of fabricated sheeting, most commonly seen in the form of linear grating. Proper design and use of tools with machinery creates a repeatable form which can be used to create products for many industries, including jewelry, aerospace, automotive, construction, civil and architectural, etc. Machining. Machining is the process of removing unwanted material from the block of metal to get the desired shape. Machining is a trade in and of itself, although fab shops will generally entail a limited machining capability including metal lathes, mills, magnetic-based drills, along with other portable metalworking tools. Welding. Welding is the main focus of steel fabrication. The formed and machined parts will be assembled and tack welded into place, then rechecked for accuracy. A fixture may be used to locate parts for welding if multiple weldments have been ordered. The welder then completes welding as per the engineering drawings if welding is detailed, or as per his/her own judgment if no welding details are provided. Special precautions may be needed to prevent warping of the weldment due to heat. These may include redesigning the weldment to use less welding in a staggered fashion, using a stout fixture, covering the weldment in sand during cooling, and straightening operations after welding. Straightening of warped steel weldments is done with an oxyacetylene torch and is somewhat of an art. Heat is selectively applied to the steel in a slow, linear sweep. The steel will have a net contraction upon cooling in the direction of the sweep. A highly skilled welder can remove significant warpage using this technique. Steel weldments are occasionally annealed in a low-temperature oven to relieve residual stresses. Such weldments, particularly those employed for engine blocks, may be line bored after heat treatment. Final assembly. After the weldment has cooled, it is generally sandblasted, primed and painted. Any additional manufacturing specified by the customer is then completed. The finished product is then inspected and shipped. Specialities. Many fabrication shops have specialty processes which they develop or invest in, based on their customers' needs and their expertise. Casting, chipping, powder coating, powder metallurgy, welding.